Hello, this is Adventurous Man. Oh, bugger. I was hoping you'd be able to see the writing there, but it looks as though it's going to be too small. Okay, anyway, I've put down some of the results that I've gotten so far. Now, sorry I cut it off so quickly the last video, I just wasn't thinking. Anyway, it took about 4 minutes to produce 50 milliliters of gas at a voltage of 3.3 voltage. The temperature outside here, outside the container, is around about 90 degrees Celsius. So that's about 240 seconds to produce 0.05 of a litre. 50 milliliters, yes, that's right. So I divided the 0.05 by 240, and that basically gave me gave me a very small sum, 0.0002 litres per second. Multiply that by 60 seconds, and that gave me 0.012 litres per minute. That's around about 12 millilitres per minute. Okay, then I did a theoretical with my original cell, which incidentally, since I count them out, has 11 pairs. Each pair obviously has a negative and a positive. Okay, so at 3.3 volt it would theoretically produce 11 times that amount there that I calculated just before, which is 0.12 litres per minute. That works out to be 0.132 litres per minute, or 132 litres per minute. 132 millilitres per minute. Sorry about that. And the theoretical approximate theoretical current would be around about 17.6 amps. Because I got 11 times the surface area, or 11 pairs, and that'd be at approximately 20 degrees Celsius, since it was running at the same temperature as it was yesterday when I did this very same experiment with the faulty port for the gas outlet. I also did the same sort of thing for the uninsulated washer. The voltage is 3.3 volts. Remember, the current started at 2.25 amps and rose to about 2.5 amps. I just said that the average current would be about 2.38 amps. When I measured it inside, it was 21 degrees Celsius, which I assume is what the temperature would be inside for that today's experiment. It took 4 minutes and 13 seconds to produce 100 milliliters of gas. It's a lot faster. So it took 253 seconds to produce 0.1 litre. So basically, working it out, for a minute it was producing 0.024 litres per minute, or 24 millilitres per minute. So it's basically twice as fast. Theoretically, with my original unit with the 11 pairs at the same voltage, it would be producing approximately 0.264 litres per minute at a theoretical current of 26.18 amps at 20 degrees Celsius. Don't know. I'll have to try that one out. If it's going to take that much, I'm going to have to get more current, because it only carries 10 amps for my power supply for that. Be interesting to see if I can sort that out and see how close that comes to being. Anyway, back over here. Running out of time. So I've set it up for 5 volt test to run it. Now I don't have enough time to do. Oh, actually I might. Let's try it and see what happens. Okay, get my trusty stopwatch. Okay, exactly the same cell as the one at 3.3 volts. I should have done this with the other one too. Would have been interesting. But anyway, incidentally, I've also shown that there is leakage current, and it does make a difference. Though the leakage current obviously produces gas as well. So I don't know. It's something I have to look into more. I need to be able to vary the voltage and the current, and work out curves and everything. I'll be working on that later on. I just wanted a general indication at this stage. Okay, well, let's turn the sucker on. Okay, the top is off at the moment. It's producing more gas. It's almost twice as fast really when you look at the bubbles, because before it was running about half the number of bubbles for the same time. Maybe it'll take twice the time. Let's see. The amperage. Let's see if you can see that. Okay, the amperage is at about 3.5 volts. A little over half. And the voltage is just under 5 volts, as indicated by that, so it's close enough. That's an indication. And look at that sucker go. Can you see it? There we go. Let's bring it back a bit. See, it's bubbling quite nicely. It's hard to see the surface there. Now notice it's not clouding too much the water. You can basically see through it quite nicely. It seems to be producing big bubbles. Now, a lot of people will be saying it's probably oxygen. I suspect that it's producing both. And I would prefer my cell to produce big bubbles, because big bubbles shoot to the surface, they don't hang around too much, and they burst, releasing that gas as fast as possible. Hopefully what that means is that you're less likely to have bubbles interfering with the making, as you would with some of the other cells. Might also explain why a lot of cells, when they start, the current has a maximum current and very quickly goes back a wee way to its working voltage. It might have something to do with the number of bubbles that are suspended in the water, perhaps. Just a wee theory of mine. I have no idea if it's true or not. Okay, so what I'll do is I'll finish this video now, and I will bring you back for when I actually do the actual timing. This is Adventurous Man, out.